Hello, today we'll be solving a question from the 2020 New South Wales, Australia Maths Extension 2 exam. And it's a complex numbers question, and it's question 13 in the paper. So let's have a look at the first part, which is part I. The first part says to show that for all integers n, e to the I n theta plus e to the negative I n theta is equal to 2 times the cosine of n theta. Okay. Solve this question. First write e to the I n theta, and using Euler's formula, we have e to the I n theta is equal to the cosine of n theta plus I times the sine of n theta. And we also have e to the power of negative I n theta is equal to the cosine of negative n theta plus I times the sine of negative n theta. Since cosine is an even function, this is the same as cosine of n theta. And since sine is an odd function, we have a minus sign and we have sine of n theta. Now we can add the two equations together. So if we add the two equations, so we see we have a cosine n theta appears 2 times, and the sine n theta or I sine n theta cancels out, and we have this identity over here. And this is exactly the same as what we need to prove in part I. So part I is complete. Now part II, by expanding e to the I theta plus e to the negative I theta to the power 4, we are trying to prove an identity involving cosine to the power 4 of theta. Okay. To expand e to the I theta plus e to the negative I theta to the power of 4, we can do binomial expansion. We have e to the 4I theta, and the next coefficient is 4, and the coefficients follow the same pattern as Pascal's triangle. So we have the coefficients 1, 4, 6, 4, 1. So we have e to the 3I theta, e to the negative I theta plus 6, e to the 2I theta, e to the negative 2I theta plus 4, e to the I theta, e to the negative 3I theta, and finally e to the negative 4I theta. Okay, now we can group some of these terms. We have e to the 4I theta. I'll group the e to the 4I theta with the e to the negative 4I theta. Okay, this is the same as e to the 2I theta, and this is the same as e to the negative 2I theta. So we have plus 4 e to the 2I theta plus e to the negative 2I theta. And now over here, e to the 2I theta times e to the negative 2I theta is equal to 1. So we just have plus 6. And now using part 1, e to the 4I theta plus e to the negative 4I theta is the same as 2 cosine of 4 theta. And similarly, e to the 2I theta plus e to the negative 2I theta is the same as 2 cos 2 theta and plus 6. So that's 2 cos 4 theta plus 4, it should be 8 cos 2 theta plus 6. And now this thing can also be written as 2 cos theta from part 1 and to the power of 4. This is equal to 16 cos to the power of 4 theta. Therefore, 16 cos to the 4 theta will equal everything in blue over here, which is 2 cos 4 theta plus 8 cos 2 theta plus 6. And now we have cos 4 theta divided by 16. This is the same as writing 1 over 8 of, so 2 divided by 16 is 8, so we have cos 4 theta here. And 8 divided by 16 is 2, so we have 4 cos theta here. And 6 divided by 16 is the same as 3 over 8, so we have 3 over here. Okay. Okay, so we have this equation. And this equation is the same as the one that we were given to prove in part 2. So part 2 is complete. Final part is to use the second part to calculate the integral of cosine to the power of 4 theta d theta from 0 to pi over 2. Okay, the final part. So we can use the previous part and rewrite cos 4 to the theta as 1 over 8 and cos 4 theta plus 4 cos 2 theta plus 3 d theta. Bring out the 1 over 8 to the front. Now we take the antiderivative of cos 4 theta, and this is sine 4 theta divided by 4. The antiderivative of 4 cos 2 theta is 2 sine 2 theta. The antiderivative of 3 is 3 theta, and this is from pi over 2 to 0. And this is equal to the sine of, so 4 times pi over 2 is 2 pi, and 2 sine pi plus 3 pi over 2. Okay, and this is minus sine 0 over 4 minus 2 sine 0 minus 0. Okay, and so sine 2 pi is equal to 0, sine pi is equal to 0, sine 0 is equal to 0. So all we are left with is 3 pi over 2 over here. Okay, so final answer is 3 pi over 16 for the integral of cos to the power 4 theta d theta from 0 to pi over 2. Okay, so that's it for this question from this HSC examination. So hope you found it useful. Thanks for watching, and I'll see you next time.